Hello everyone. Welcome back to the series of natural language processing. Till now we have learned that convolution neural networks are used for image processing. Now the question is, can we use these convolution neural networks for text classification tasks like sentiment analysis? Yes. But how? Let's see in this video. We know that in TensorFlow Keras, convolution neural network is made up of conv 2D layer. This conv 2D layer include the filters of different sizes. For example, the filters might be 3 by 3, 5 by 5, 7 by 7, etc. And these filters convolute across the image both horizontal and vertical directions. That's why these are conv 2D layers. Now let's try to understand how we can use convolution neural networks for the text. We know that we cannot process the raw text directly. It has to be converted into numeric. Let's say the input text with the 7 words, I love the new design of website. These are the indexes generated for these tokens across the entire vocabulary to convert them into the numeric vectors. Let's say 50 dimension embedding layer for each of the word token in the text. Let's assume a maximum sequence length of each input text is 20, including padding. Here the padding didn't shown in this picture, but remember that. So the maximum sequence length of each input text is 20. So each of these words in this input text will be represented by an embedding vector of dimension 50. Assume these are the corresponding word embedding vectors. Now over this matrix we are going to convolute a filter. But the filter size will be the size of each word vector. So we are going to define a filter which occupies the complete size of the word. Let's say the kernel size is 3. Then it creates a matrix with 3 rows and each row of dimension 50. Okay. Now, so that the filter size might be 3 by 50. And this filter is now going to convolute over the embedding layer with the first 3 words, and you will get the first value of the convolution operation. Then the convolution will be performed on the next 3 words likewise and generates the next convolution value. Thus, this filter convolute over this image in only one direction with provided striding equal to 1. You can see here the next 3 words convolved and so on, and the last 3 words convolved here. So as this convolution over this image is going on in only one direction, top to downwards, provided with the striding equal to 1 time step position at a time. That is why it is called conv 1D in TensorFlow Keras. Now this is the convolution of the first filter across the entire text image. So with the input of size 20 and the kernel size 3, the convolution output will be 20 minus 3 plus 1, which is equal to 18. Thus, we will get 18 output values with each convolution with a filter, with a single filter. The same is repeated with the second filter like this. It started with the first 3 words of the second filter, and then the next 3 words, and so on, and the last 3 words of the entire embedding layer of that particular sentence. Thus, just assume we have defined 250 such a filters for convolution operation. So for every filter, you will get 18 outputs like this. Okay. Now, what do you do next is to do global max pooling. In global max pooling, what happened is that for every filter, if you look at the outputs and take the maximum values like this, this is the maximum value in this particular convolution operation, and this somewhere in between, and so on. And here is also somewhere in between, and so on. This was highlighted with the bold. In our case, as we have 250 filters and each filter is having 18 outputs, from these 18 outputs you will get to 250 maximum values. This is global max pooling vector, which is the output of the global max pooling 1D layer. This is how a conv 1D works on the text data. Now let's go to Google Colab notebook to see how to use this in text classification task with a sample of data. The first is we need to import the required libraries, TensorFlow and the NumPy, and the tokenizer, as we need to divide the text into the tokens, which is a part of the TensorFlow Keras pre-processing text library. And as all the sentences is of equal length, padding must be done. Padding is nothing but importing with the zeros. So in order to do the pad sequences, that we can do from the pad sequences library that is being imported, and we are going to build a sequential model with the embedding layer, conv 1D layer, global max pooling 1D layer, and the corresponding the dense layer for the last stage output generation. So let's see. We are going to take a sample tweets. There are 80 tweets are there we have taken with the corresponding labels. If you look at this, these labels are either representing either positivity or negativity of the T's by the labels 0 for negativity, 1 for positivity. If you look at the first tweet, I love the new design of the website, is a positive, so the corresponding label will be 1. This is the worst product I have ever bought. There's the second tweet, so its worst is representing the negativity of the negative sentiment of this is, so the corresponding label is 0. And you can see that another one also, absolutely fantastic services. This is the third sentence, accordingly it's representing the positivity, so the corresponding label is 1. So for all the 80 tweets, the sample tweets that we have taken for the sample data set, and the corresponding labels have been taken into this. This is the input and the output that we are going to. Now the task is classifying a given text into positive or negative class, finding the label, determining its label either positive tweet or negative tweet, classification, sentiment analysis. Nothing but the binary classification task of the given task. These are the parameters that we have taken for our model. The maximum number of tokens that we have taken defined is the 5,000 words in the entire vocabulary, and maximum length of the sentence is 20. Here we have taken a sample sentences of 8 to 10 words only, but the maximum length we defined, which makes the uniformity of all the sentences is 20, because it is a sample data set. We have chosen it as the maximum length 20. And the embedding dimension, each word will be represented by the embedding vector of dimension 50. And the batch size we defined it to, and model is going to be trained for number of epochs 5. The next step is, the first step is the text cannot be processed as it easily, it is to be converted into the embeddings. So the first step is divide this is tokenization. First of all, we define the defined tokenizer was initialized. Here in the first line of the code, we initialized the tokenizer object from the keras preprocessing.text with the number of words specifies the maximum number of words to keep based on word frequency. Only the most common this we have defined is 5000, so that the most common first 5000 words will be used in the vocabulary. And in the next line of the code, this will update the internal vocabulary of the tokenizer based on the list of the text, nothing but the tweets. It creates the word index based on the frequency of each word. And this is the line of the code which converts each text in the tweets to a sequence of integers, so that each integer will represent the index of the word in the tokenizer dictionary. And this is the line of the code which pads the sequences to ensure that they all have the same length, and that is the maximum length. That way I have defined is the 20. So generally this padding is typically done by adding zeros to the beginning or end of the sentence sequences. So anyhow, the default is the pre-padding. I mean to say, adding the zeros to the beginning of the sentences. And this is the line of the code which converts the list of the labels into the numpy array, which is typically required for input to machine learning models. And in the next step is we need to split the data into the training and testing data. So we have a set of 8 inputted tweets. So the first 6 were divided into the defined into the training set, and the remaining 2 are taken into the test set. Because it is the sample data, I'm showing like this. This is how the data is split into train and test data sets. Once this is done, then we are entering into the most important, that is called defining the model. Coming to the building the model, we are specifying our model is the sequential model, which is appropriate for a plain stack of layers, where each layer has exactly one input tensor and one output tensor. And the first layer is embedding layer. In embedding layer, we specified that we are dealing with the 5000 unique words, and each word will have a vector of size of 50, and the input length is the maximum length, which is nothing but the 20 that we defined in the parameters of this model. This is how the embedding layer was defined. So what is the job of this embedding layer? If you see, it is to form the word embeddings for 5000 unique words of size 50. So that the input to the next layer, conv 1D layer, will be a matrix. So the next layer is the conv 1D layer. Here is the conv 1D layer. We are using a filter of size 3. Likewise, we are using 250 such filters with the activation as a ReLU, and the padding is taken as valid, which is nothing but no padding. This means the convolution window will only move within the valid part of the input, and the strides we have chosen is 1. That is nothing but the number of positions the convolutional window moves at each step is 1. We can use these filters of different sizes, 2, 3, 4, 5, 7, and so on, etc. So and the length of this filter will be 50, because this 50 is nothing but, as we are using conv 1D, this 50 is the output dimension of the embedding layer. So each filter length must be 50. If we are using the filter size is 2, the meaning that we are considering the pair of words, that is also called as the bigrams. If the filter size is 3, then it is called the trigram convolution, which considers 3 consecutive words. Thus the different filter sizes can be considered. And the next layer is the global max pooling 1D layer. This layer performs downsampling by taking the maximum value over the time dimension for each time step. I mean to say, for each filter. So that this reduces the tensor's dimensionality and helps to focus on the most important features detected by the convolution layer. Once this is done, and then the next is the fully connected dense layer with the 250 neurons and the relay activation. Then it is connected to the last dense layer, which is the output layer with only one node, as it is for the binary classification task, with the sigmoid as the activation function. How this model was defined. Once the model is defined, then we need to compile the model by specifying the binary cross entropy as the loss function, Adam optimizer, and defining the accuracy metrics. Then if we look at this model summary, we can see this model summary how it is looking this. Just look at the output shape of the embedding layer. So the embedding layer is defined with the 50 is the embedding dimension, and the maximum length of the input is 20 including padded. So the output will be, and for n number of samples you will get 20 is the sequence length, each sequence or each word of dimension 50. Then it will be input matrix for the convolution 1D layer, where you will get the convolution operation. Here the convolution operation taken is the 3 with the 3 channel. I mean 3 filter sizes, kernel size is 3 with the 250 filters. Such a 250. So output dimension for the convolution 1D will be 250. With the dimensions is now it coming to the calculation. The input is 20. So 20 minus this 3. 17 plus 1 is 18, so that you will get 18 values, convolution values, output values for each of the each filter of the convolution operation, so that you will get the output for the 250 filters. Then it will be given to the global max pooling 1D layer, where it will get the maximum value, so that for 250 filters you will get to 250 values. So 250 element vector will get generated. This is what the output shape is representing. Then it is connected to the 250 node dense layer and final dense layer with one node. Okay, once the model is compiled, then we need to train our model with the data set, whatever the training and test data set that we defined here in this one. So the model is trained by calling the fit method. Xtrain and ytrain is input, and with the specified batch size 2 and the number of epochs 5. And the validation data set, we consider the test sample itself is the validating data, where it is there are 2 samples only we are having. Okay, once the training is over, then the model is evaluated and the same test data set, and the score is displayed. We can see the score that is generated is the test accuracy is a 50% accuracy. Don't bother about the accuracy here in this model, because this is the model built on the sample data set of 80 tweets only for the demonstration purpose. Okay, right. You can see some of the interpretations that we have taken out this one. Each said there are 80 tweets, each of the length 20. I mean to say sequence length is 20. 20 is the maximum sequence length we defined. You can display this. How is the sequences will be visible, that also we can see it here. Across the 5,000 unique words across the vocabulary, you will get 5,000 by 50 is the entire dimension of this embedding matrix that we can see here. Yes, there are, if you look at what are the models of this, what are the layers of this model, we can see the first is the embedding layer, second is the con 1D, third is the global max pooling 1D layer. So looking at considering the first layer, embedding layer, I am trying to display the embedding matrix size and the shape, so that we can understand what is the maximum. 5,000 unique words are there for each of this unique word is represented by a 50 element vector, so that the dimensions of the embedding matrix is 5,000 by 50. Each embedding vector is a 50 element vector. Once the model is done, we just try to predict the output of the model, do the predictions on the model by passing the same training data sets of first 6 samples. Model by calling the model.predict by passing the xtrain. This is the output that we got. final outcome of the entire model. Yes, 6 values for the 6 input sentences in the first training data set. Yes, for all these 6 sentences we got the 6 values. Just cross verify this one. So the values that we got, if you see the output values that we received and got, 0.5, it is the sigmoid activation function. So 0.5 above greater than or equal to 0.5 will be considered as the label 1, and less than else will be considered as label 0. So in this case the first is label 1, second is label 0, third is label 1, fourth is label 0, fifth is label 1, sixth is 0. So we converting into the label vector, you will get 1 0 1 0 1 0. These are the labels that have been predicted by the model for the input of first 6 samples. Let us cross verify with the data that we have chosen. Yes, for the 6 sentences what we got is 1 0 1 0 1 0. Exactly, it is matching correctly. Let's just check with the remaining 2, because the training data only we tested, we got it clear. So if I change it is the remaining 2 sentences 6 onwards is the data that we passed to check the predictions. Yes, we got the values 0.49 0.49, but the label is 0 0 only. I mean to say the last 2 sentences have been predicted by our model as label 0. Both are the negative sentences, but it is the wrong predictions. Yes, fifth sentence is 1 correct, but the last 1, but the last is 0. So here is the mismatching, is a misclassification was done. That is because we got the accuracy is 50% only. This is how the interpretations can be done. Hope you understand well about how the Conv 1D will works for the text classification and the concept of text classification using CNN. Thank you.